Welcome to APA's first webinar for 2021. My name is Billy Zedek, Manager, Special Projects for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to APA's webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through the end of 2021, and many are open for registration now. Professional continuing education and AIA CLUs are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @apa.org, along with your AIA membership if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. At this time, it's my pleasure to turn this over to Peter Kesser. Peter, take it away.
Thanks, Billy. Welcome to everybody. We appreciate you taking the time to join us today. I am the Global Vice President of Sales for Alchemco. Alchemco is a manufacturer of concrete and masonry waterproofing products. They're integral products that work below the surface of the concrete, and they're a bit unique in that they are very long-term waterproofing for decades, as a matter of fact. And so what we're going to talk about today is how that can help reduce your maintenance cost by actually doing long-term waterproofing as opposed to having to redo it over and over again. As we start here, before we really jump into the presentation, I wanted to give you an idea of some of the projects that have been done by Alchemco around the globe, just so you get a scope and scale of it. In the lower right-hand corner, we've got an indoor water park in Bahrain. In the lower middle, a medical center in Qatar. They did the concrete cooling towers there. Upper right, you see an airport parking structure at an airport in Australia. Museum in Portugal, and you'll notice that this looks like bare concrete. It's designed that way. One of the nice things about our products is that it does not change the appearance of the concrete when it waterproofs. Again, it works inside the concrete. There's the Christ the Redeemer statue down in Rio de Janeiro, Brazil. Okay, why is this not advancing? Here we go. Baseball stadium, aquarium in Norway, church in Italy with a unique concrete structure on the left. In fact, you can see the guy applying the product there. On the right, we've got another concrete looking structure down in Brazil, power plant in England, the main airport in Rome, a highway bridge, a new construction bridge in Vietnam. So it kind of gives you an idea. It's really anything having to do with reinforced concrete, especially exposed reinforced concrete. We did win the Most Innovative Product Award at the World of Concrete in last February in Las Vegas. We're pretty excited about that, especially considering that our technology has been around for 45 years already. So just to be considered still innovative is really a good deal. So let's jump into the presentation. So how do we reduce maintenance spending? And one way to do that is to waterproof the structures for decades instead of just 5 to 10 years. Concrete's one of the most utilized construction materials in the world, but it will deteriorate if it's not properly protected. You can, there's a variety of waterproofings out there, integral and non-integral, so on the surface as well as below the surface. So the main key here is really to increase that sustainability and durability of the structures, whatever they are, water tanks, parking structures, stadiums, bridges, you name it. What we're going to be going through here today, the first part is going to be understanding why waterproofing is important. Second will be to identify some of the main causes of concrete deterioration. Third is going to be to discuss the common types of waterproofing applications that are used in the North American marketplace. Then we're going to finish up by talking about new construction projects, so new concrete and using crystalline technology, admixtures in there. And then finally, we're going to talk about how long-term waterproofing can protect your concrete structure for decades. And this is using a spray applied below the surface technology. So the first one, why is it important to waterproof concrete structures? Because certainly concrete can last a very long time. It's the most widely used construction material in the world. Back to Babylonian times, in the 1700s, they added cement and that changed the mixture. It's really still a simple mixture. You got cement, aggregates, and water in the most cases. You're maybe adding in some admixtures of various types to make it cure properly or quicker or anything, but concrete by its nature is permeable and porous. It has voids and capillaries. It'll crack, so you'll have fractures in the concrete. And all of those things can allow water and or chemicals to migrate into the concrete and start causing problems. And they're not going to fix themselves. You're going to have to really make sure that you take care of them. And it really can be one of those pay me now or pay me later things. If you protect the structure up front, it can last a long time. If you wait until it starts deteriorating, then you have to deal with the problems as well as the waterproofing. Some of the advantages of concrete: low cost, non-flammable, eco-friendly. It has high stiffness rating, high compressive strength. There's ease of fabrication, and you can form it into some very neat looking structures. But there's disadvantages: low tensile strength, brittleness, lack of a long-term durability in its most basic form. Premature deterioration can be cracking, spalling, corrosion of the steel reinforcement. And as I said, it's both permeable and porous. Permeability is how easily fluids move through the material, and steps have to be taken to mitigate that. And then porousness is really the size and how many of those pores are in the concrete. If water and chemicals are allowed to penetrate in, they are going to cause it to deteriorate prematurely, and in some cases that can be very costly to fix. We had a project here, not last summer, but the summer before in St. Louis, parking structure where the waterproofing itself was a couple $100,000 to waterproof the structure, but they had to spend almost $1 million to do structural repairs to it before they could waterproof because they had let it go so far. Some of the things that can happen: spalling, stress cracking, freeze-thaw cracking, chloride ion penetration, especially if you're up north from the snow melt to get the ice and snow off, hydrostatic pressure problems in containment tanks, and then corrosion of steel reinforcement. The problems that are shown here in the last few slides are going to cause concrete to deteriorate, and it all has to do with water getting into the concrete in the first place and starting to cause the problems. So we're going to talk about properly protecting it, and we'll take a look at some of the main factors that cause it to deteriorate in the first place. So you got weather, temperature, moisture, humidity. You've got improper concrete mix can cause problems. Chemical interactions within the concrete can cause corrosion. You've got carbonation, chloride ion migration, as we discussed. There could be design flaws that can cause the concrete to crack, and then just poor construction and installation practices. All of those things put the structure at risk. And as I said, even though concrete is durable, it is going to deteriorate over time. Temperature, moisture, chemicals. If you take a look in the upper right-hand corner here, you see a little diagram. Upper left-hand part of that diagram, you've got a cross-section of a concrete slab that's healthy. It's got a steel reinforcement in it. Water, chemicals, etc., get in. That steel reinforcement bar starts to corrode, and it grows, and there's nowhere for it to grow in the concrete, so it cracks it. Pretty soon that crack goes all the way to the surface and starts letting even more bad stuff in, and eventually it spalls the concrete, and as you see in the picture on the bottom, you've got exposed steel reinforcement. Now you have to, again, repair the concrete before you can even attempt the waterproofing. Carbonation is another version of that, and that is a chemical reaction that's going to lower the pH in the concrete. Again, the same end result. It ends up corroding the reinforcement and it starts coming through the concrete. And then the chloride ion migration. If you're on the coast, this can be salt water. As I said, up north, this is primarily the ice melt that gets used on the roads, gets tracked on the bridges, into parking structures, things like that. Design flaws, if they don't design for the right structural capacity, they don't adequately accommodate for thermal shift, and they don't properly plan for shrinking or settling, any and all of those things will cause problems with the concrete structure. And then you've got poor construction and installation practices and too much water, various things, different things will cause pitting, honeycombing, stress cracking, shrinkage cracking, thermal stress cracks, tension cracks, all of those. So as structures are being built, there's a lot of things that need to go right for this to work properly. Waterproofing it with the right system will help that longevity happen. So now we're going to talk about the commonly used methods of waterproofing that are out there in the North American market anyway. So both integral and non-integral systems, so inside the concrete and on the surface. While the intent here are the same, to prevent water and chemicals from penetrating, the methods they use are different. And so again, we're going to talk about the North American market. There's sheet membrane waterproofing, and that is either self-adhesive peel and stick or thermofusible torch-on membranes. A lot of times those are used in below grade applications. You've got fluid applied waterproofing membranes, hot rubberized asphalt, cold fluid applied membranes and coatings. And then you've got integral waterproofing systems, both the crystalline technology and the modified silicate gel technology. The self-adhesive peel and stick, these are generally modified bitumen sheets. They have asphalt, they're asphalt-based products. The adhesive is factory applied, and then you've got a plastic sheet that's pulled off and it gets applied to the surface. Proper surface prep is necessary for this, and good conditions, because otherwise you're going to have problems with it doing its job properly. Because it's adhered to the surface can't have voids in it. You can't have mechanical damage, other trades banging into it or dropping tools on it, things like that. And it's prone to potential problems at penetrations and angle changes where you have to do certain details. Thermofusible torch-on are also asphalt-based products, and they use a torch to liquefy the asphalt, and that becomes the adhesive that holds it onto the concrete. Again, these are a lot of times these are used either on plaza decks or sometimes below grade. And you have the same issues. You have to make sure that the product doesn't get damaged by other trades, things get dropped on it, and no problems where the seams are or around penetrations, things like that. You've got your fluid applied waterproofing, either hot rubberized asphalt where they're heating it up in a kettle and pumping it to the area, or carrying it in pails, and they're spreading that out. These are temperature sensitive applications. It has to be done within a narrow temperature band. You've also got cold applied, where they're actually squeegeeing out. Some products are asphalt based, others are polyurethane. There's a lot of different types of liquid membranes that can be used, but again, generally they're spread out and squeegeed out in layers. They can be applied, they're applied to the positive side of the wall or the structure, so in between the water and the concrete. And the biggest issue with them is if they get damaged or deteriorate over time. Then on the integral waterproofing membranes, you've got crystalline technology. This can either be an admixture, a powder that gets put into the concrete at the beginning, and it's mixed in so that when the concrete is poured, it's already got the waterproofing material in it. That waterproofing material will react with the calcium hydroxide that's in the concrete and start creating crystals that help to block those voids and cracks and things to prevent water from migrating in. Then you can also use this crystalline technology on the outside of the structure in a slurry. They take the powder, they mix it together with water. Generally, it's brushed or broomed onto the surface. Can also be sprayed with a heavy-duty industrial rig, and it's watered, and the chemicals migrate into the concrete and form those crystals. Here you see it being brushed on by hand. Now, these will change the visible appearance of the concrete because you're putting it on the outside. And lastly, you've got the modified silicate gel. These are spray applied. These are liquids that are sprayed onto the concrete surface. They penetrate below the surface. They react with the chemicals that are inside, the calcium and stuff that's inside the concrete, and they form a gel that forms a penetrating barrier just below the concrete surface, usually a half to 3/4 of an inch below the surface. And that prevents water and chemicals from getting in down to the steel reinforcement. These are clear and colorless. They don't change the appearance of the structure at all. They literally penetrate in. They don't change the slipperiness coefficient. Doesn't get more or less slippery. The concrete surface ends up being exactly the way that it was before. These have a capability of self-healing the concrete. So not only do they form a gel that fills all the cracks when they're installed, but the chemicals stay reactive, and when water hits them, because concrete cracks later, it re-gels and fills the new crack. So now we're going to talk about newly poured concrete and how to make that more sustainable. And we're going to basically talk about the admixtures here, the crystalline admixtures that we mentioned before. They can be surface applied, but in this particular case, we're going to talk about the powder that gets put into the concrete. There are a lot of different types of admixtures. They'll speed up the hardening, etc. This particular type of admixture is simply to waterproof the concrete. And because it's put into the concrete when it's poured, it goes through the entire slab, the concrete slab, as opposed to the gel, which is just below the surface. Excuse me. So it mixes with free lime and calcium hydroxide inside that concrete to create those crystals. In fact, in the upper left-hand corner and upper right-hand corner, you can see microscopic photographs of those crystals being formed. Using admixture method to waterproof means that the system is not relying on workmanship, right? This is not something that's being put on afterwards, so you don't have to worry about any potential workmanship errors. This is the only thing you have to worry about is that it gets properly mixed so that the chemicals are all the way through the concrete. It creates a system that's very durable. It can't be damaged because it's inside the concrete, so you don't have any membrane to tear or delaminate or decompose or anything. These are VOC free, so the concrete is recyclable when you get to the point where it has to be torn down. And it can be used pretty much anywhere structural concrete is being poured. So waterproofing of foundations, slabs, walls, water storage tanks, wastewater treatment plants, potable water tanks, elevator shafts, parking garages, basements, secondary containment centers, swimming pools. Any and all of that are good applications for this product. And then now we're going to look at the modified silicate gel. And this is going to be for existing concrete structure. So this kind of falls more into the preventative but also maintenance end of things. These can be sprayed on in a number of ways. One common way for smaller areas is with a backpack sprayer. You can see here we've got a guy doing it on a vertical surface. This is kind of an interesting project, actually. This was a floating dry dock. This particular project off the coast of Hawaii. Floating dry docks go out to sea, they submerge under a ship and they lift it up out of the water so that the hulls can be worked on. And this particular one had a concrete hull as opposed to the steel hulls that they usually have. Anyway, they put it in the water, and within a few hours it was leaking through the concrete hull, so they had to pull it out of the water, spray clean it. They spray applied the modified silicate gel around the entire surface, and it's a very fast application. Within less than a day and a half, they had the project complete, and the floating dry dock was back in the water and starting to do its job. Unfortunately, I had a video clip here, but the links didn't seem to be hot. So I was going to show the formation of the gel, putting two of the chemicals together. So there are 3 steps to applying this type of a product. The first step, and you see the gentleman here has the backpack sprayer on again, is after you've done the cleaning and prep work that you would need to do for any waterproofing project, you're going to continuously spray excuse me, the entire surface. This product goes down at about 200 square feet per gallon coverage rate, and using a backpack sprayer, they can do about 3,000 square feet an hour. So it moves along pretty rapidly, and you can put several people in backpack sprayers on. It can be done vertically or horizontally. This is actually on a below grade wall that is going to be backfilled against once the waterproofing is complete. If you've got bigger areas, you can spray directly out of the 55-gallon drum. This is kind of the recommended way, and when you have projects of any size. And a 2-man crew here can do 15 to 20,000 square feet an hour. And just to give you some comparison, some of the traffic coatings and things that get used in parking structures, you're going to have a 6, 7, 8-man crew, and they're going to get about 10,000 square feet done in a day. And this is going down at about 15 to 20,000 square feet an hour. So much quicker. And that translates into less downtime for that structure. Then after that dries, the next step is to water the project in, and this is just flooding the area. That starts getting the chemicals, driving them into the concrete and starting to form the gel. After that dries, the second step is to use a crack and void type treatment that makes sure there's plenty of calcium at any existing cracks. And then following that, you would spray the entire surface again with the accelerating agent, which is just what it sounds like. It helps that gel form more quickly inside the concrete. And then after that is dry, there's one more step, and that is to water it again. These type of products love water. The more water they get, the more gel forms and the more waterproof the concrete becomes. After you spray this, after you do this system, again, this is a chemical reaction, so it's going to take 3, 4, 5 days for the gel to form and fill all those cracks and voids. But even after that, it will continue to form gel for months and months. And that gel, those chemicals stay active, as I said, below the surface, so that when the concrete cracks again in the future, water will penetrate in, it will hit the chemicals, it'll create the gel and fill the crack immediately and not let the water get down into the concrete slab and affect the steel reinforcement. There's also flashing work that gets done with these around drains at angle changes, and that's kind of a reinforcement. So the area does get waterproof first, but then it would get caulked at the angle change, and the flashing material that gets put over it. So here's a real quick comparison just using a parking structure. Let's say it's a 100,000 square foot parking structure. Maybe it's 3 levels of 33,000 square feet each. Normally you'd have a 6, 7, 8-man crew to put a traffic coating system on a parking structure like this. As I mentioned, with the other type, the modified silicate gel, you're talking about generally 2 or 3 guys. And to do this project with the traffic coating system, so a primer, a base coat, a mid coat, a top coat, the sand, you're going to have about 2 semi-loads of material, 42 pallets of material. And let's say you had a 6-man crew, it would be 10 days to do the project roughly, so 640 man hours. By comparison, the spray applied silicate, you're talking about a 2-man crew for probably 5 days. So 80 hours versus 480 man hours. You're talking about 6 pallets of material instead of 2 semi-loads. And you could put a 4-man crew on it and get it done in half the time. The other thing is you're not taking 2 semi-loads full of empty 5-gallon pails that had solvents in them out to the landfill. So it is an environmentally friendly way to waterproof your structures as well. Because you guys are involved in long-term ownership of the structures, we're going to just go through some life cycle comparison here so you see what happens over time. Because this, again, for long-term owners, this can become a big thing. So if you assume that a 50-year lifespan for a lot of the concrete structures, that's what a lot of the engineers and architects tell us they're designing. Some bridges and things as much as 75 years, but a lot of people seem to think right in that 50-year range is what they design them for, and then hope they last longer. So if you take that 50-year time scale and you say that, okay, when we waterproof this, it's going to be 100% waterproof. No matter what system we use at that moment, it's going to be doing its best job of waterproofing. Well, in the case of the modified silicate gels, because they keep forming gel and keep reacting, it actually gets more waterproof as time goes along. And if we assume that we have a 5-day shutdown of that structure, like we said, in this typical 100,000 square foot structure, we said 2 guys for 5 days. If you figure it's about $30.50 a square foot for the application, and again, this is not all the prep and everything, but $3.50 to $4 a square foot, you got about $350,000, and it's going to last you the entire life of the structure. If you are using, say, that traffic coating system, whichever one you pick, usually those are 5 to 10 year systems, maybe a little bit longer. We just kind of picked 7, 8 years as a comparison before they start to fail and you have to re-waterproof them. And let's just say that costs $4.50 a square foot, which can be low for that type of a system. And we already said it was going to take 10 days for that 6, 7, 8-man crew to shut down to do the project. That's going to start to deteriorate, and over some time, it's going to really fail, and you've got water leaking into that concrete and causing problems. So you're going to have to waterproof it again. You're going to have to probably grind off the coating, do some repairs, reapply. Let's just say that would be another $450,000. And if you assume that you stayed up with the maintenance and stuff, you could be doing it quite a bit over a 50-year period. You could be talking millions of dollars instead of hundreds of thousands, and you could have downtime of a few months as opposed to a week. So it just gives you an idea of the life cycle. The modified silicate gel falls into that integral waterproofing category. So you've got an absence of seams, lower overall cost, protects the steel reinforcement from corrosion. It's environmentally friendly, allows the concrete to be recycled. These products are vapor permeable, so they let the concrete breathe. They don't trap moisture in the concrete. And it's not compromised by poor site conditions, poor membrane workmanship, or worksite damage. Modified silicate gels are a proven technology. They've been used on projects around the globe for over 40 years. There haven't been a lot of them used in the United States, and that's one of the reasons that we're doing what we're doing, is to educate and let everybody know about this technology. But back in the mid-1970s is when our particular products started being used on projects around the globe. They actually use water. We say foe becomes friend. They actually use water, which is the bad thing, right? We don't want water in the concrete structure. Where they're actually using water as a transport mechanism to get those chemicals down into those cracks and pores so that it can form the gel. As I said, it leaves the latent chemicals behind, embedded in the concrete matrix, so that when there is other cracking and water comes in, it will gel up and fill those cracks. Fast application, like I said, 15,000 square feet an hour is not unusual at all. That means less downtime if you're shutting down your football stadium or your level of your parking structure or water storage tanks or anything like that. It does leave the surface unchanged, both visibly but also from a practical standpoint. So if you've got historical structures and you can't change the appearance, this is a really nice application. But even on other things, you can do whatever you want to the surface afterwards. So once you've waterproofed, if you want to put an aesthetic coating on it to make it look a certain color, if you want to paint stripes on the parking structure, or if you want to put hot asphalt pavement, like you're paving a bridge. We do that on bridges quite a bit, where they'll waterproof the concrete structure and then pave over it. Any and all of those things can happen with these type of products. In addition to the fast application rates, they're easy to apply. There's no real big costly equipment. Backpack sprayers can be used. Drum pumps can be used. They do get into some spray rigs. The DOTs use them on the highway bridges, and they will have a truck outfitted with a spray rig that's a lane or a lane and a half wide, and they'll just slowly drive the truck forward, and they really get some production there. It also is a densifier. It increases the hardness of the concrete surface, 6 to 8 on the Mohs scale, which I think is granite. We've done some testing, and let's say a concrete slab in a parking structure, say 3,500 PSI to start with. After this has been applied and everything is cured, it will test closer to 5,000 PSI. Now, just that 1/2 to 3/4 of an inch, not the whole slab, but as far as drive surfaces, like for instance in parking structures and the on and off ramps, it will make it more durable. So to kind of recap here, some of the pros of using this kind of technology: fast to install, simple spray equipment. It has very good hydrostatic pressure ratings, 1,300 feet, becomes an integral part of the substrate. It's reactive. It will seal cracks up to 2 millimeters wide when it's put on, and up to 0.4 of a millimeter wide afterwards. So basically hairline cracks later. It allows concrete to outgas the moisture, highly resistant to chemicals, non-toxic, VOC-free, no slip-resistant issues one way or the other. Don't have to do any surface priming or leveling. There's no laps to come apart or seams to come apart. Can be applied on the positive or the negative side of the concrete surface, although it's really recommend the positive side to prevent the water from getting into the concrete. As I said, it's a densifier, less costly to apply than a lot of the other methods. Can't deteriorate because it's inside the concrete. It actually increases the bond strength between cementitious materials. Really, the only downside is the concrete surface has to be clean and dry before you do the next application. So we mean dry to the touch. So once you do a step, you have to wait a couple hours for it to dry. That depends on ambient conditions, of course. And then you can start the next step. Just to give you an idea, we do like to do demonstrations, small area demonstrations. So this one happens to be the basketball arena at Iowa State. We did this about 1.5 years ago, I think. The pedestrian bridge here on the left, the elevated pedestrian bridge coming in, that's on the right, that's this area. And they had some cracks through the slab they had identified. So we did our treatment on, I think it was about a 400 square foot spot over where the cracks were. So they'd been leaking for a couple of years. It was actually cracks all the way through the slab. Here you can see the before. We watered the top, and within a minute or so, it was leaking through the slab. Here's those same areas afterwards. And so once we applied, they did a water test for 3 hours. You got a sprinkler here and a hose, and they just kept drenching it like it was raining for 3 hours. And you can see the water pouring off here down to the area below and still dripping here, but you can see those areas are bone dry. And in this particular case, after this, they asked us to come over and look at the football stadium and said there's some leaking over there, and they're putting a scope together for doing part of the football stadium. So some case studies on on the modified silicate gel, just to give you an idea again of what has been done in the U.S. This is the Lowe's corporate headquarters in North Carolina. 15 years ago, they did these 2 parking structures here, and it's worked out so well that about a month and a half, 2 months ago, they just did another parking structure there because they had seen the 15-year performance. It's still dry, no problems, no reapplications, and so they just finished another section of a different parking structure. Miami International Airport, this was done first phase in 2010. That was 1 ramp, 350,000 square feet, all 7 levels. And then 5 years later, they did the next ramp, so the Dolphin and Flamingo ramps. This was a parking structure that was 25 years old when they did it in 2010. And they were, in this case, they were fighting high humidity, salt environment, because right by the water. And you also had jet fuel residue and other contaminants that they were fighting against. Peterson Event Center up in Pennsylvania. They did the concourse and decks and steps. This is a parking structure at a resort in Myrtle Beach. Back in 2006, they did all the levels there. This is actually a newer one. They just did this in July. This is the basketball arena at Colorado State. You see this raised area here that goes around. I think they did half of that, and then the weather closed in, and so I think they're talking about in the spring when the weather breaks doing the other half. And then they were also talking about the football stadium. This is kind of a unique project. This is over in Australia, a resort, and this pond here is built over an underground parking structure. So there's a parking structure under this. If this was leaking, it would be leaking right into the structure. This was done in 1988. And so for over 30 years, it's been keeping the water out of that parking structure. It also has had plants growing in it and fish swimming in it. So again, this is water potable certified. It's passed the NSF 61 test for drinking water. So it's very environmentally friendly. This is a parking structure that was done a couple summers ago at Purdue in Indiana. Here's another longer term one. This is a top level of a parking structure that was done in 1988. What makes this a little bit unusual is 5 years later, they hired an engineering firm in 93 to go do a water test, came back 100% watertight. And then they had another firm in 2017, so 30 years almost after the application, they did another test. That's what this one is. And in this case, they located 3 of the PVC pipes over where the original cracks were leaking, and then 3 just on the regular concrete. And so again, over 30 years with no maintenance performed, no additional waterproofing, just still performing. This is a parking structure, I think, at Indiana University in Bloomington a couple years ago. Parking structure at a hospital in Georgia back in 1999. Parking structure up at Logan International Airport. This was a new construction community in San Diego, 300,000 square feet. This was done over a 3-year period. This was balconies, parking structure, walkways, etc. This is another interesting one. This was done in 1986. This was Pittsburgh International Airport. They did 1 million square feet of runway in 3 days, 72 hours. You can see they built oversized spray rigs here so they could really get some production going. And they got 1 million square feet done in 72 hours. This is the Petrobras terminal down in Brazil. This just kind of talks about the chloride ion protection in the salt water. There's that water park we were talking about in Bahrain at the very beginning. You can see they're doing the watering here, but it was 200,000 square feet of water area. This is a soccer stadium in Brazil that was built in 1936. In 2010, they acid etched all this. You can see the before. They acid etched the whole area. Then they waterproofed it with a modified silicate gel, and then they came back over the top with a aesthetic coating because they wanted the different sections to be different colors. Piedmont Hospital in Atlanta. This is another couple of parking structures phased. And then lastly, I think this is a new construction bridge in Vietnam. I was telling you, they waterproofed the concrete structure and then paved over that. This was in 2013 and 14. So there are a number of different products and installation methods to waterproof concrete. Most of them are designed to be fairly short term. You've got your spray silenes and things that are maybe 2, 3 to maybe 5 years. You've got coatings that'll last 2 or 3 years up to maybe 8 or 10 years. A few of the high cost ones will last a little longer than that. The modified silicate gel is really a long-term waterproofing that can go up to 50 or 60 years from a preventative standpoint, saving lots of money, not having to budget. Because if you think about it, if you do a waterproofing system that is going to last maybe 10 years, when you come back in 10 years, it's not just spraying or rolling on new stuff. And in many cases, you've got to etch off or shot blast off or grind off the old coating down to the concrete, do repairs that might be needed, and then do the next level of waterproofing. And you've got to do that and again. Even if you ground off the top 1/4 inch of concrete, if you did that 3 or 4 times, you've just now taken an inch off of your concrete structure, and you're getting really close to where that steel reinforcement bar is. So anyway, that's the end of the presentation. I think we've left about 15 or 20 minutes to ask questions if you've got any. And just to let you know, we've got an entire waterproofing system, all of the products that are needed, as well as certified applicators that are trained by our factory field techs to do the work properly. We can actually offer a 15-year labor and material warranty for existing structures, and then a 30-year labor and material warranty for new construction projects. So compare that with maybe a 2 or a 5-year material only warranty that you're going to get from some of these other waterproofing products. This is long-term commitment, and Alchemco is, because we've got the 45-year track record, we're happy to warrant those. Okay, so questions, anybody?
Yes, Peter, we have quite a few questions coming through. First question,
okay.
Freeze-thaw cycling has been the biggest concrete killer in the Northeast. Has that effect been tested for this product to avoid surface spalling?
Yes, so I'll say this. This product has been used on 5 continents. It's been used in cold weather, warm weather, high altitude, low altitude, and in every different type of setting you can imagine. Again, water tanks, reservoirs, parking structures, space needles, everywhere and anywhere. Because it is a liquid construction material, we recommend that application happen at 40 degrees and rising, and below 100 degrees, but that gives you a pretty wide range in there. But once it's inside the concrete and activated and the gel is there, there's no problem with weather conditions. And as I said, this will prevent the water from getting into even new cracks that get formed. And so therefore, there is nothing to create problems in a freeze-thaw situation. Because it's a gel, I think it handles the thermal shock a little bit better than the crystalline. We've got both products. We've got crystalline and gel. I think the gel handles that a little bit better than the crystalline-based products do.
Okay, thank you. Next question. What is the wet dynamic coefficient of friction on a finished walking surface?
It would be exactly what it was before. And if you want to get more information from that, I can certainly get you in touch with our technical director and they could go through that. But in effect, it does not make it more slippery. It does not make it less slippery. And you're able to adhere anything to the concrete that you could before. So again, if you want to paint it, if you want to put a coating on it, if you wanted to put tile over it, no matter what you wanted to do, it would be just as the concrete surface was before.
Okay, thank you. Does this product work for face brick or multi-wipe brick masonry?
Yeah, we have a masonry product that works using the same type of a chemical reaction. It doesn't have the long-term performance and labor and material warranty, but it's a very good watertight sealant, if you will. It gets sprayed on the entire surface. But primarily it's waterproofing the mortar. It's going to penetrate into the mortar, work with the calcium that's in there, form that gel to help protect that. And we generally figure that that is a 7 to 10 year type of application, and then you spray it on again and protect it again.
Okay, thank you. Next question. Are there limitations to vertical surfaces versus decks?
No.
Okay. Next question. Can you describe the process for prepping existing concrete?
That's a good question, and it really varies depending on the project conditions, which is why we didn't really get into it. But it can be as simple as, maybe it's a 2-year-old parking structure and it needs to be power washed, or it maybe needs a detergent and then power washed kind of a thing, all the way to acid etching or shot blasting or grinding off an old coating in order to get the surface prepared properly. What we need to have is a clean, dry surface with open concrete pores. So if there's been some type of a sealant on it, or let's say it's a parking structure that has oil and gas and radiator fluid and everything, dripped in and stained in the concrete, we have products that get that out of the concrete. If there's anything there that would prevent water from going in, so if, like, you put a sealant on it and water beads up, if the water won't go in, it has to be removed, because we use water to transport our chemicals into the concrete. So we need those open pores.
Okay, thank you. Has this product been used on exposed aggregate walking surfaces, and can a Lustre seal be applied on top of it in exposed aggregate conditions?
Yeah, so it's not what the product is designed for. It's designed to fill small gaps in high density concrete. Can it be used? We've seen it used in a lot of different applications. Concrete block, for instance, right, is not particularly dense concrete. It will work. The coverage rates are lower, and it's not a long-term warranted. But if it's got access to calcium, which is naturally in concrete, we need 3 things to form the chemical reaction and form the gel. We need water, we need the modified silicate, and we need calcium. Those 3 things combine to create that gel.
Okay, thank you. What about the application to surfaces that have previously been sealed with a different product?
Yeah, so we have to remove those. And again, sometimes that is, sometimes that's just as easy as acid etching, and we've got a nice organic acid product for etching that's very safe to use. Sometimes it ends up being shot blasting or grinding off the existing coating or whatever it is.
Okay, thank you. And it looks like we have one final question. Is the product rated for subsurface vault use?
I'm sorry, rated for what? Subsurface?
Vault use.
Vault?
V-A-U-L-T.
Yeah, I don't know that it's been tested for that. It is used commonly in below grade applications. I don't know that we've been tested for that particular one, but we can certainly find out.
Okay, well, I'll send this gentleman's contact information and let you get in contact with him. Well, at this time, we have no further questions from anyone. I'd like to thank Peter for taking his time to do the presentation today. And I'd like to thank all of our attendees. I know this is not one of the easiest times that we've been living through, but hopefully 2021 will make it much better. And I hope to see everyone at our next webinar. We'll start our series on a weekly basis starting in February. So stay tuned and look. Make sure you look at our web page for all of the upcoming webinars. So for now, I'll say thank you. Be safe. Stay healthy. Until next time. Goodbye, everyone.
Thanks, everybody.